So hello guys and welcome to my channel. Today again I'm back with another important numericals on machine designs. And here you can see numerical on the screen. A laminated tooth of armature steel in an electrical machine is 30 long and has a taper such that the maximum width is here 1.4 times the minimum. The maximum width is 1.4 times the minimum, and estimate the mmf required for a mean flux density of 1.9 Weber per meter square in this tooth, and use Simpson rules. The B curve the B80 curve for the material of tooth is given here, and here B and 80 here for 1.6 it is 3700. Similarly for 1.8 it is 10,000, and similarly the other value is given here. And here starting with the solution, first let WT1, WT2 and WT3 be respectively the maximum, mean and minimum width of the tooth. Now in the questions here it is clearly mentioned that the maximum width is 1.4 times the minimum. So maximum width we have assumed WT1 as a maximum and WT3 as a minimum and WT2 as a minimum. So WT1 is equal to 1.4, WT3 as mentioned in the conditions. So these are our given conditions, and WT2 we have assumed this as a mean. So for mean it will be WT1 plus WT3 upon 2, so that will be 1.2 WT3. Now let BT1, BT2, BT3 be respectively the minimum, mean and the maximum flux density. Now here you can see BT1 as BT1 is equals to BT2 into WT2 upon WT3. We have the relation. So BT2, and here estimate the maximum flux density for the mean flux density. Here we have the mean given as 1.9 Weber per meter square flux density. So BT1 will be BT2 into WT2 upon WT1. So BT2 in place of BT2 we have 1.9 into WT2. So WT2 we have 1.2 WT3, and again WT1 is 1.4 WT3. So you get 1.9 into 2, 1.2 upon 1.4. So it is going to give 1.63 Weber per meter squares. Now BT3 will be BT2 into WT2 upon WT3. So 1.9 into, and WT2 is here we have 1.2 WT3, and again WT3 and WT3 cancel out, so we'll directly write here 1.2. So we'll get 2.28 Weber per meter squares. And now here for BT1 1.63 here we have. For BT1 81 is 4500 ampere, and BT2 is 1.9. So for BT2 given in the questions as 1.9, so for this we have 17,000 amperes, and BT3, so for BT3 2.28 Weber per meter squares, 83 is 100,500 amperes, and this value is taken from the curve BT to 80 curve, and here I have not plotted the curve, so simply you can use the interpolation technique. So here I will show you how to use the interpolation technique here. So here first for 1.63 we have 4500, for BT3 1.9, and here you can see in the table for 1.9 the value is already given, and that is 17,000 ampere per turns, and the value for BT1 equal to 1.63, and this value is not given. So for that I will suggest you to use the interpolation technique. So here I will show you how to use the interpolation technique here with the help of calculators. So here we have first press mode, and then in option 3 you will see the option of stat. So press 3 here, and in option 2 you will see the option of a plus bx. So press 2 here. Now we have to calculate the value of 1.63, and here 1.63 lies between 1.6 and 1.2 1.8. So here first we will press 1.6 press equals to, and then 1.8 and then again press equals to. Now For 1.6 we have 3700, so 3700, and similarly for 1.8 where we have 10,000, and then press equals to. Now press this AC button. Now press shift and press 1. So in option 5 you will see the option REG. So press 5 now, and now press again 5. Now press these buttons, means left, and now we have to calculate the value 1.63. so press 1.63, so 1.63, and now press equals to. So you get here 4645, and here we have taken 4500 from the curve. So you can simply take the value with the help of interpolation techniques, or you can plot the curve. So here similarly you can calculate for BT3 2.28. so for BT3 2.28 we will get the value as 100500 amperes, and sometimes the value is already given in the questions, so you do not have to use interpolation technique, or you do not have to plot the curve for that. Simply use the value given in the questions. Now, and here we have to apply the Simpson rule. So for Simpson rule, here we have 80 min is equals to 81 plus 482 plus 83. So we have obtained the value of 81, 82 and 83. Just we need to substitute here, and we will get the value of 80 min as 28833 ampere per meters. Now total mmf required will be 80 min into LT, and LT is given as 30 mm, so on calculation we will get here 865 ampere. And here we have, you can see the 30 mm long is given, length is given. So finally we will be able to calculate the total mmf required. So total mmf required is 865 ampere. Hope you enjoy the lectures. Thanks for watching, and please don't forget to subscribe to my channel. Thank you.